Am I audible to everyone?
Yes, sir.
Is the board visible, guys? Is the board visible, all of you?
Yes, sir.
Yes, sir.
Right. Right. So we have discussed regarding Young's double slit experiment. We have discussed regarding interference. Right. We have discussed regarding diffraction as well. Let us try to see the left out thing, which is polarization. We'll quickly complete this. We'll discuss the questions also, and I will share the test paper with you people. I'll ensure that the test will be active till tomorrow morning, guys. Okay, because I don't think uh, everyone can write the exam as soon as the uh, class is done. Or let us see how we can manage that particular thing. Right. So polarization again, it is also a phenomena of light, and in general, when I talk about light, guys, light is an electromagnetic wave, as you all know, right? And whenever we consider electromagnetic wave, it will be moving with speed of light. In vacuum, it is going to move with 3 into 10 power 8 meter per second. So if I write C value, we know it will be given as the ratio of E divided by B. So what is ER? It is C times of B, because C is very much greater, guys. So C value is, we know it is 3 into 10 power 8. Yes or no? So as C value is 3 into 10 power 8 meter per second, what we can tell from this situation? Can I say E value will be very much greater than that of magnetic field value or not? So in general, we know light is a electromagnetic wave. Electromagnetic wave basically consists of oscillating electric field and magnetic field, which oscillate in mutually perpendicular directions in phase with each other. So light should actually contain oscillations of both electric field and magnetic field. But what we assume is, because C value is 3 into 10 power 8, we will get electric field as 3 into 10 power 8 times the magnetic field. So we'll imagine that the electric field can be much more greater than magnetic field. So I'll just say that light can be considered to contain oscillations of only electric field. In reality, it will contain what and what, guys? It will contain oscillations of both electric field as well as magnetic field. But because the electric field strength is 3 into 10 power 8 times the magnetic field strength, that is the reason we can simply imagine light to consist of oscillations of only electric field. Is that point clear, all of you? Yes or no?
Yes, sir.
Right. So whenever light is again, if I say that electric field, light is consisting of oscillations of electric field, if the electric field vector is oscillating in n number of randomly oriented, it contains electric field randomly oriented in different directions, such type of light will be called as unpolarized light, guys. Right? And if light contains electric field directed in one particular direction, guys, then such type of light will be called as polarized light. So the phenomena of conversion of an unpolarized light into a polarized light is called as polarization. Is that clear, all of you? Understood, everyone? Basically, light is an electromagnetic wave. It should consist of oscillations of both electric field and magnetic field. But strength of electric field is 3 into 10 power 8 times the strength of magnetic field. So I'll imagine light to consist of oscillations of only electric field. So light will contain electric field vector randomly directed in all directions. Such type of light will be called as unpolarized light. Right? If light contains electric field vector directed only in one particular direction, such type of light will be called as polarized light. So the phenomena of conversion of unpolarized light into a polarized light will be called as your polarization, guys. So polarization basically will be done by using three ways. One will be by using a polarizer analyzer combination, as you can see. The second one will be polarization by scattering, guys. And third one will be polarization by reflection, refraction, which also you can see. Right. So what is polarizer again? I think you might have studied solid state again in chemistry. So polarizer is simply a crystal, guys. It is a crystal on which unpolarized light is incident. So I can represent unpolarized light something in this manner. It will contain oscillations of electric field in two perpendicular directions, we can write. What is analyzer? It is also a crystal, but on which polarized light is incident, guys. On which polarized light is incident. So what I'll do first, we will take unpolarized light. So electric field vector is randomly directed in all directions, guys, for unpolarized light in this manner. So you can take something like this. This is our unpolarized light. It's because the electric field is directed randomly in all directions. So I can represent unpolarized light. So we know, can I resolve this into two perpendicular components or not? All of them I can resolve. So I may get either something like this, right? Or I will get something in this manner. So this is our unpolarized light, guys, right? So I can consider them to contain electric field vectors in two perpendicular directions. In reality, it is in different directions again, randomly oriented in different directions. But I can show unpolarized light like this. So how will I show polarized light, guys? I can either say polarized light will be something in this manner, or simply like this I can take, or in this manner. Electric field vectors random directed in one particular direction only. So this is our unpolarized light. This can be taken as our polarized light, guys. So just to show you, I'll show it with the help of fingers again. So let us imagine unpolarized light. So these are your Y oscillations and Z oscillations, guys. I'm just showing it. Dots are Z again, but in order to make you visible, I'm just taking it like this. Okay, this dotted line is the transmission axis of polarizer, guys. Okay, what is the significance of the transmission axis? So if I consider unpolarized light, when it is made incident on polarizer, transmission axis of polarizer is this, represented by my forefinger, guys. So when unpolarized light is incident, this particular transmission will allow all those electric field vectors which are along the transmission axis, and it will reject all those electric field vectors which are perpendicular to the transmission axis, guys. So what we can consider, we can take it. So these components will get rejected and these will come out. So as you can see, unpolarized light, basically it will contain electric field vectors randomly directed in all directions, right? So I am writing it or representing it as an equivalent two dotted, or you can consider uh, two directions, guys. Electric field in two perpendicular directions we are assuming. So did you understand this? Did you understand the significance of transmission axis, guys? What will transmission axis do? It will allow those electric field vectors which are along the transmission axis. It will absorb those, guys. Similarly, it will reject those electric field vectors which are perpendicular to the transmission axis. I hope it is clear, all of you. Is there any doubt in this, everyone? Am I audible?
Yes, sir.
Hello. Is there any doubt?
No, sir.
Right. So when, what is polarizer? It is a crystal on which unpolarized light is incident. What is analyzer? It is also a crystal, but on which what will be incident, guys? Polarized light will be incident. So you can represent these two as your unpolarized light and either one of them as your polarized light. I hope it is clear. Yes or no?
Yes, sir.
Yes, sir.
Right. So if unpolarized light has intensity I naught, so here the intensity is equally distributed in two perpendicular directions in lines and dots, guys. But what had happened to dots? The dots are removed now when they are incident on polarizer. So only lines are there. So polarized light will have how much intensity? I naught by 2. So now after passing through the polarizer, I have only these components of electric field. Okay. Now initially, you see, I'm just representing with the help of I'm just representing with the help of fingers, guys. So originally the forefinger was transmission axis of polarizer. Let us imagine, right? This is transmission axis. Another forefinger is transmission axis of analyzer, guys. They both are inclined to each other by a certain angle theta. Okay, if I can just show it here. So this is our transmission axis of polarizer. So what is the angle between them? So they are inclined to each other by an angle how much? Theta. So what I will do to this polarized light is, again I'll resolve it into two components, guys. So what was the original light now? Polarized light was something like this. Yes or no? What I'll do is, I will take two components. I will take one along the transmission axis of analyzer, and other component perpendicular to the transmission axis, guys. So here I'll take two components again. So I'll resolve it something in this manner, like this and like this. Both are again perpendicular to each other. So now you see our transmission axis is in this manner. Now I have two components again, right? I have two components in this manner, guys. One are these component, the other is my forefinger again. The transmission axis is like this. So whenever polarized light is incident on analyzer, what is the function of transmission axis, guys? It will allow electric field vectors which are along its direction, and it will reject electric field vectors which are perpendicular to its direction. So overall, will I get an electric field vector which is along the transmission axis of the analyzer or not? Finally, did you understand that, all of you? Yes or no? And as per
Yes, sir.
Malus law, the final intensity will be I naught by 2 cos square theta, guys. I hope it is clear.
Yes, sir.
Is that clear, everyone?
Yes.
I'm explaining once again, polarization, especially polarization by polarizer analyzer combination, is very important. I'm explaining once again. Please listen carefully, guys. Light basically is an electromagnetic wave. It should consist of oscillations of electric field and magnetic field. But because the strength of electric field is much more greater than the strength of magnetic field, we will assume light to consist of oscillations of electric field only. So if electric field is oscillating in such a way that electric field vector is randomly oriented in all directions, such type of light will be called as an unpolarized light. If electric field vectors are oscillating in such a way that they are particularly aligned in one particular direction, or they are aligned in one particular direction, such type of light will be called as a polarized light. The conversion of an unpolarized light into polarized light is called as polarization. It can be done by three ways: by using polarizer analyzer combination, by scattering, and by reflection, guys. What is polarizer? It is a crystal on which unpolarized light is incident. What is analyzer? It is a crystal on which polarized light is incident, right? So what we are doing, we are considering unpolarized light to be incident on polarizer. The transmission axis of polarizer is like this, guys. Okay, and this is our unpolarized light. So unpolarized light is made incident on polarizer. What will the polarizer do, or what is the significance of transmission axis? It will allow all the electric field vectors which are along its direction. So these electric field vectors it will allow, guys. However, these electric field vectors it is going to reject. Okay, so that is the reason what got transmitted. I got electric field vectors directed in one particular direction only. So this will be a polarized light. When polarized light is incident on a crystal, that crystal is called as analyzer. I am assuming theta to be angle between the transmission axis of polarizer and analyzer. So this was our polarized light, and I have transmission axis in this manner, guys. Okay. So what I am doing, this polarized light, I am resolving into two components. One I will resolve along the transmission axis of analyzer. Other I will resolve perpendicular to the transmission axis of analyzer. Now I have got how many components? There are two components which are like this. Yes or no? This is one vector. This is one vector. Our transmission axis is in this manner. Okay. So polarized light is now incident on analyzer. What will the transmission axis of analyzer do? It will allow only those components which are parallel to it. So finally, what light will come out? The light with electric field vector along the transmission axis of analyzer is going to come out. Is this point clear, everyone? Yes or
Yes, sir.
no?
Yes.
Right.
Yes,
Now,
sir.
intensity of unpolarized light, if I take I naught, after it is coming out of polarizer, it will be I naught by 2. Once it comes out of analyzer, it will be I naught by 2 cos square theta. Intensity, as you all know, it is proportional to amplitude square. Let us say unpolarized light has intensity A naught, guys. Okay. So here, what is the intensity? I naught by 2. So what will our amplitude be, guys? It will be A naught divided by root 2. Yes or no, all of you? What is intensity beta? It is proportional to amplitude square. The amplitude will be proportional to root over I or not. So here root I naught will be A naught. Root I naught by root 2 you will get. So A naught by root 2 will I get or not, guys? What will be the intensity finally for this light? It will be A naught by root 2 cos theta. This is also very, very important again. I hope it is clear, all of you. Yes or no? So this is our resulting amplitude, guys. Okay, it is not given here, but these are our resulting amplitude. If I imagine polarized light has intensity I naught only, guys, then polarized light which is finally coming out of analyzer will have how much intensity, beta? I naught cos square theta. Understood? So this law is called as Malus law or law of Malus, guys. Is that clear, everyone? Yes or no? Yeah.
Yes, sir.
Polarization by scattering is not that much necessary, guys. So basically when light is passing through atmosphere, so inside dust particles you will have electrons, guys. So electrons will absorb that light and it will be scattering it in different directions, guys. So it will be scattering in different directions. So the light which is scattered in all directions will be partially polarized except for that, and in perpendicular directions whichever it is scattered it will be fully polarized, guys. Okay, so that is polarization by scattering, which is not that much essential again. So whenever light is passing through atmosphere, inside atmosphere there will be dust particles, inside dust particles there will be electrons, right? So electrons will absorb the light again and they are going to scatter it in different directions except for its line of vibration. They are going to absorb energy and they will start vibrating. So while they are vibrating, they are going to scatter the light in different directions, guys. The light scattered in all directions will be partially polarized, whereas the light scattered in a direction perpendicular to the line of vibration, that will be fully polarized. So, but that is not necessary because question has never been asked from polarization by scattering. Let us talk about polarization by reflection, guys. Now, whenever light is incident at an interface separating two transparent media, guys, at any arbitrary angle, in that case, what will happen? Refracted light and reflected light, they will be partially polarized. When light is incident at a particular angle called as Brewster's angle, then in that case, reflected light will be fully polarized, refracted light will be partially polarized. Now, because I have to take unpolarized light, guys, so let us imagine I'm just showing it in this manner. So, unpolarized light will contain, well, will consist of electric field vectors randomly directed in all directions or not, guys. So, this is our unpolarized light. So whenever it is incident at any arbitrary angle, what will happen to reflected light? It will get partially polarized, guys. So it will get polarized something in this manner. Whereas refracted light also, it will get partially polarized again. In this manner you will get. So it will be something like this. Whereas whenever unpolarized light is incident at a particular angle called as polarizing angle, in that case reflected light will get fully polarized, refracted light will still be partially polarized only. And in that case, reflected light and refracted light will be moving perpendicular to each other. And what is that angle called as? This angle is called as your polarizing angle or Brewster's angle. And the second case will be called as Brewster's law. So that IP value, as you can see, IP value will be given as tan inverse of mu, you can write, or I can write IP value as tan inverse of mu2 divided by mu1, guys. Clear? And what is critical angle? Critical angle, as we know critical angle is sine inverse of what, beta? Mu1 divided by mu2. So if I use both of them, I'll get a relation between them, which is tan IP into sine IC will be equal to 1, guys. And in 2018, you got a question based on statement directly, guys. How will reflected light get polarized? They will ask you, right? Reflected light will get polarized with its electric field vector perpendicular to the plane of incidence, guys. If I can just show you, if I imagine, again, if I take unpolarized light, something in this manner, right? So how will reflected light be? Fully polarized, guys. And how will it get polarized? With its electric field vector perpendicular to the plane of incidence. However, refracted light will still be partially polarized, guys. It will still be partially polarized. Clear, all of you? Yes or no? So what you need to remember is intensity you remember as well as amplitude you remember, guys. How will amplitude vary also is very important. Any doubt in this?
Could you explain the scattering means?
Scattering का उतना जरूरी नहीं है यार. Whenever light is ordinary light is unpolarized light basically. When it passes through atmosphere, it gets absorbed by dust particle or electrons present in the dust particles. So as they absorb light, light will consist of energy. Electrons will start vibrating. So once they are vibrating, they are going to emit radiations. Radiation again will be in the form of light only. So how will those radiations be? They will be partially polarized to maximum extent. Whereas in one particular direction, what is that direction? A direction which is perpendicular to the line of vibration. In that direction, whatever light is scattered, that will be fully polarized. These 2 points you need to remember, as simple as that in scattering again. Okay.
Sir, can you repeat polarization by reflection again?
What point do you want me to repeat?
Sir, about two cases, unpolarized light and in polarized light you gave me.
Reflected light and refracted light. They will be partially polarized when unpolarized light is incident at any angle. कौन से भी एंगल पे अगर इंसिडेंट हो रहा तो unpolarized light will get reflected and refracted. How will that reflected and refracted light be? They will be partially polarized. But when unpolarized light is incident at a particular angle called as Brewster's angle or polarizing angle, in that case, reflected light and refracted light will get polarized. How will reflected light get polarized? Fully or completely polarized. How will refracted light be polarized? It will still be partially polarized only. In this case, how will reflected light get polarized? With its electric field vector perpendicular to the plane of incidence. So this second case is called as your Brewster's law. Understood? And
Yes, sir.
in this case, reflected ray and refracted ray will move perpendicular to each other. So what is that angle at which unpolarized light should be incident for reflected light to get fully polarized? Brewster's angle, tan inverse of mu, or it will be given as tan inverse of mu2 by mu1. So because critical angle is given as sin inverse of mu1 by mu2, we have a relation between polarizing angle and critical angle, which is sin IC into tan IP will be equal to 1. Clear?
Yes, sir. Thank you, sir.
There is something, there is also something called as Doppler effect in light, guys. Just like we have Doppler effect in sound, in the same manner we have Doppler effect in light as well, right? So basically, if I consider the frequency, how is frequency given, beta? We write h nu as hc by lambda. So frequency can be written as c by lambda or not, guys. So how is frequency? Depending on wavelength, it is inversely proportional to wavelength. Lesser the wavelength, more will be the frequency. Yes or no? So there we study source of sound. Here we will study source of light, guys. So if I take source of light and observer, this will be the line joining source and observer. Right? We are already aware when source moves towards the observer or observer moves towards the source, what will happen to frequency? Increases. What will happen to wavelength? Decreases. So this phenomena, because wavelength is decreasing, this phenomena, this decrease in wavelength will be called as blue shift. In the same manner, whenever source is moving away from the observer or observer is moving away from the source, frequency decreases. It means wavelength increases. So this increase in wavelength is only called as your red shift, guys. And whatever shift in wavelength is there, we will do only using one formula again, right? That formula happens to be delta lambda by lambda will be equal to V divided by C. What is delta lambda here? It is shift in wavelength. Lambda is the original wavelength. What is V? V is the speed of source relative to the observer along the line joining source and observer. In Doppler effect in sound, guys, we will only take those components which are perpendicular to the line joining source and observer we will take. Sorry, which are along the line joining source and observer we are going to take. In the same manner, What is V here? It is the speed of source relative to what, beta? It is speed of source relative to the observer and along the line joining source and observer, guys. C is anyhow your speed of light. You are going to majorly use this formula only, and there is one more formula, delta nu by nu. We write it as minus of delta lambda divided by lambda. So these two formulas we will use in case of your Doppler effect in light, guys. Clear, everyone? Is that clear, all of you?
Yes, sir.
Yes, sir.
This is the basic concept which is necessary in your wave optics topic, guys. Any doubts in this, everyone?
No, sir.
All of you guys. Let us do some questions. With that, you will get much more clarity and you will be able to understand this topic even more clearly, guys. Is the board visible, all of you? Is the board visible, everyone?
Yes.
So what they have given is, in Young's double slit experiment, distance between the slits is 3.73 lambda. So D value is given as 3.73 lambda, guys. They're asking what is the number of maxima that can be obtained in upper portion of the screen, excluding central maxima, they're asking. Okay. Now, how to find maxima and minima, I'll tell you. Although I thought of telling yesterday, but as I said, if any question is asked, I'll explain here. In Young's double slit experiment, in general, what is path difference, beta? Is it d sine theta or not? Again, for maxima formation, what should path difference be? N lambda, which is equal to d sine theta. Right? So from this, can I write sine theta value as n lambda divided by d? And we know sine theta usually lies between what and what, beta? -1 and +1. So I can write this as n lambda divided by d less than or equal to +1. So here minus d divided by lambda less than or equal to n less than or equal to plus d divided by lambda you will get. This is the condition to find maximas, number of maximas formed, guys. So whatever integral values of n we have, those many number of maximas will be formed. So here what did they give? D value is given as 3.73 lambda. Yes or no? So what will d by lambda value be? It will be 3.73. So what will n value lie between? N value will lie between minus 3.73 as well as plus 3.73. Can you please tell me what are integral values of n here? Integer values, guys. N value -3, -2, -1, 0, 1, 2, and 3. These many integer values of n we have. So please tell me 1, 2, 3, 4, 5, 6, 7. So how many maximas will be formed? 7 maximas will be formed, out of which n is equal to 0 will correspond to what, beta? Central maxima. They are saying excluding central maxima. So you remove one central maxima. How many are there now? 3 and 3. 6 are there. They are asking only in the upper portion. So how many will be formed, beta? 3 maximas will be formed in the upper portion. 3 maximas will be formed in the below portion, guys, lower portion. And n is equal to 0 will correspond to central maxima. Is that clear? So what is the condition to find maximas, number of maximas? Minus d by lambda less than or equal to n less than or equal to d by lambda. Whatever integral values of n we are getting, whatever integral values of n we are getting, those many number of maximas will be formed. Here they are not asking total maximas, guys. They are asking only those maximas which are formed on the upper portion, that too excluding central maxima. So how much will be the answer? 3 will be the answer, guys. Clear, all of you? Is that clear?
Yes, sir.
Right? That is the situation. In the same manner, you are also going to have, for if I talk about in general, let us say for minima also, guys. For minima, if I'm explaining what is the condition, I'll write you how to find it. So in general, what will you write? Path difference again. How much should be path difference, beta? Path difference, you know, it will be d sine theta. For minima, what will path difference be? 2n minus 1 lambda divided by 2 should be equal to d sine theta. So from this, what will I get? Sine theta value, I will get it as 2n minus 1 into lambda divided by 2d. And we know sine theta should lie between what and what, beta? Minus 1 and plus 1. So if you solve for this, you are going to get, I think you will be getting it as, what is the condition I'm writing directly, guys? If you solve, you will get lambda minus 2d divided by 2 lambda less than or equal to n less than or equal to lambda plus 2d divided by 2 lambda. This condition we are going to use in order to find number of minimas again, guys. Clear? So whatever integral values of n we have, those many number of minimas will be found. I hope it is clear, everyone. Did you understand? All of you guys.
Yes, sir.
So number of maximas condition क्या है? Minus d by lambda less than or equal to n less than or equal to d by lambda, right? And number of minimas condition क्या है भाई? Lambda minus 2d by 2 lambda less than or equal to n less than or equal to lambda plus 2d divided by 2 lambda. Whenever lambda and d relation is given, then only I can find out maximum, the number of maximas formed and the number of minimas formed, guys. I hope it is clear, all of you.
Yes, sir.
That's right. Next question, let us see. Light emitted from a distant star is observed at a frequency 5500 megahertz for the star stationary with respect to us. If the star is approaching us with speed 3 into 10 power 5 meter per second, then what would be the observed frequency they are asking, guys? Right? So what is the observed frequency they are asking? So whenever the star is a source of light here, guys. The source is approaching the observer. What will happen to frequency? Increase or decrease?
Increase.
It will increase. And what is the formula that we are going to write? We know delta lambda by lambda can be written as v by c again. So here you can write delta nu by nu can be written as v divided by c. From this, what we can also write, beta? Delta nu value will be, what is v value? What is the speed of the star given as? 3 into 10 power 5. What is c value? 3 into 10 power 8. Into what will I write? Nu. So can I write this as nu divided by 1000 or not? So we got it as 5500 divided by 1000 megahertz you are going to get, which will be how much, beta? 5.5 megahertz. So this much increase you will have. So what is the frequency heard or frequency received by the observer? It will be original frequency plus shift in frequency. Why plus I'm writing? Because star is approaching us, guys. So I'll write it as 5500 plus 5.5. What will I get? 5505.5 megahertz. I hope is this clear? Is this clear, everyone? 5505.5 megahertz. Okay, direct formula again. Definitely questions you will get based on Doppler effect in light, guys. What will we use? Frequency is inversely proportional to lambda. So I can write delta nu by nu as minus delta lambda by lambda. I can also write delta lambda by lambda as v divided by c. C is speed of light. V is speed of source relative to the observer along the line joining source and observer. Clear? Is that clear, all of you? Yes or no?
Yes, sir.
Yes, sir.
Let us be little bit interactive. If not, I will sleep, guys. Huh? I have slept only for 4 hours to be precise. Huh? So if you don't shout no in my ears, then ऐसा खत्म हो गया. Two coherent sources with intensity I0 and 4I0 respectively interfere in a medium. Coherent sources are given. Intensities are given I1 and I2. The maximum intensity of resultant wave is n times the minimum intensity of resultant wave. The value of n square they are asking, guys. So what do we know regarding maximum intensity? Chapter kya hai? Maximum intensity, it is root I1 plus root I2 whole square. Yes or no? Yes or no?
Yes, sir.
Yes,
Yes.
sir.
So what will you get this as? I'll get it as root I naught plus root 4 I naught whole square, which is 2 root I naught. So will I get it as 3 root I naught whole square beta? Will I get this as 9 times of I naught maximum intensity? What is minimum intensity, guys? It is root I1 difference root I2 whole square. So I'll get it as again root I naught difference root 4 I naught whole square, which turns out to be root I naught minus 2 root I naught, which will be again minus root I naught. So I'll get it as minus root I naught whole square, guys, which turns out to be I naught only. What they are saying here is the maximum intensity of resultant wave is n times the minimum intensity, it seems. So what is maximum intensity from this? 9 I naught will be equal to n times of I naught. So what will n value be beta? 9. They're asking us to find value of n square. How much will be n square value? 81. Clear?
Yes, sir.
Yes or no, everyone? Maximum and minimum intensity formulas again you should be aware of. Next question, let us see. What they have given in the next question is, in Young's double slit experiment, spacing between the slits is 0.03 mm, means small d value is given. Wavelength of light used is lambda. If the angular width of the fringe formed on a distant screen is 1 degree, right, then the value of lambda is how much they're asking. So what is angular fringe width given by? What is angular fringe width given by beta? We have done this, no? It is given as lambda divided by small d or not? Yes or no? Everyone, yesterday we have taken where beta is fringe width. It is given as lambda capital D by small d. Whereas lambda by small d will be called as your angular fringe width. They are asking us to find value of lambda, guys. What will lambda value be? It will be alpha into d. So what we can write lambda value as 1 degree is given, guys. So I need to convert it into radian again. So you all know 180 degrees will be pi radian. So I'll get this as pi by 180. This is our alpha value. And what is our d value, beta? D value you are going to get it as 0.03 mm is given. So I can write it as, initially I can write it as 3 into 10 power minus 2 mm, or eventually it will become 3 into 10 power minus 5 meters, guys. Okay, so this is in radian and this is in meters. So what we can do, so 3 ones, 360s you will get. So you have almost 3 again, right? So you have almost 3 here, 3.14 we have. So I can write it as 0.314 divided by 6 into 10 power minus 5 into 100 by 100. If I do, you will get 31.4 divided by 6 into 10 power minus 7 meters, guys. Okay, right? So what are we going to get? 5.2 something you will get, guys. So 5233, I think. So this will be 5233 angstrom. Clear, everyone? Yes or
Yes, sir.
no? We are talking about angular
Yes, sir.
fringe width. Angular fringe width will be given as lambda divided by small d. And always remember, the angular fringe width should be taken in radian. What is the relation again? 180 degrees will be equal to pi radian. So 1 degree can be written as pi by 180 radian. Clear? Is that clear? I hope it is clear.
Yes,
Yes, sir.
Next question, if you see, the slit width of a single slit diffraction such that n maxima of double slit experiment patterns are obtained within central maxima of diffraction pattern. Please understand. What is the width of central maxima in diffraction? What is width of central maxima, guys, in diffraction? In diffraction, if I take, what is width of central maxima? If we talk about width of central maxima, Arey, Chepandra Babu, what is width of central maxima? It is 2 lambda capital D divided by small a, where small a is the width of the slit. What they are saying, the slit width, how much should be the slit width such that n maxima of double slit interference are obtained within central maxima. So within this much width, how many maximas are formed, beta? N maximas are formed. So what we can write, n into what would be width of each maxima in interference pattern? lambda capital D by small d should be equal to 2 lambda capital D by small a, you can write. Okay, so from this what we can cancel out? Capital D, lambda, lambda. They're asking us a value. What we can write a value as? You can write it as 2d divided by n. Understood? What they are saying is, within the width of central maxima of diffraction pattern, you have n maximas of interference pattern. So what is the each width of each maxima in interference? Lambda capital D by small d. Like that, how many maximas are there? N maximas are there. So n into lambda capital D by small d should be equal to 2 lambda capital D by small a. So I'll get width of this slit as 2d divided by n. Understood this question also?
Yes, sir.
Yes.
Next question, let us see. A polarizer and an analyzer. Polarizer and an analyzer are inclined to each other at 45 degrees. Okay. So initially what we will do is, if this is our polarizer, I will consider this to be analyzer. Their transmission axes are parallel to each other. Whenever their transmission axes are parallel to each other, maximum light will come out of the analyzer, guys. So let us just try to, I'll make you understand here in this case. So initially, let us say, please listen very, very carefully. This is polarizer transmission axis. This is analyzer transmission axis. First, I am taking which light, beta? Unpolarized light we are taking. It is made incident on polarizer. Which light will come out? Will you get this light or not? Again, this light is falling on this transmission axis. So again, will you get this much light only or not, guys? So please tell me here, if intensity is I naught. Here, if intensity is I naught, what will be the intensity here? I naught by 2.
I not by
What
2.
will be the intensity here again? I naught by 2 only.
I not by 2.
So 100% transmission of light will be there when the transmission axis of polarizer and transmission axis of analyzer, they are parallel to each other or anti-parallel to each other. Clear, all of you?
Yes,
or
sir.
no?
Yes,
So
sir.
for two positions of analyzer, one is 0 degrees, other is 180 degrees, you will have maximum light transmitted out of the polarizer analyzer combination. Okay, now what I'll do is, I will start rotating the analyzer, guys. I will start rotating the analyzer. So obviously its transmission axis will also rotate or not? Yes, its transmission axis is also going to rotate. Now this is the transmission axis of polarizer. Let us imagine this became the, I'll just take different dotted lines for understanding in a better manner. This is our transmission axis of analyzer, guys. So this is transmission axis of polarizer. Now what has happened? I'm rotating it. So as you rotate, this will be transmission axis. So initially we have unpolarized light that will be incident on our polarizer. From this, what I am going to get? I am going to get a polarized light like this, guys. So our electric field vectors are in this manner. However, how is the transmission axis of analyzer now? It is in this manner. This is our polarized light. This is the transmission axis. Will the polarized light be able to come out of the analyzer?
No.
No. So in this case, is there any light finally? No light at all.
No.
Right? So this is when polarizer and analyzer transmission axis are perpendicular to each other. Crossed polaroids we call them as. For crossed polaroids, their transmission axis will be mutually perpendicular, right? For 90 degrees position and for 270 degrees position, will there be any transmitted light? No. So for two positions, no transmitted light. For two positions, maximum transmitted light. For all other positions, Malus law it will follow, guys. Clear? So initially, these are our, this is transmission axis of polarizer. This is transmission axis of analyzer. As you rotate the analyzer, transmission axis will rotate. For two positions, you will have minima, dark fringes. And for two positions, you are going to have maxima, bright fringes formation. Clear, all of you? Understood, everyone?
Yes, sir.
Right. So that was the
Yes, sir.
situation that you need to know again. Now, what is the meaning of crossed polaroids? Those polaroids whose transmission axes are perpendicular to each other. This point also you should be aware, guys. Okay. So a polarizer and analyzer are inclined to each other at 45 degrees, it seems. Intensity of polarized light emerging of the analyzer is 2I0. So what are the conditions again? You all know. Unpolarized light, I0. Okay. Out which is incident on polarizer, guys. And what is the light which will come out here? I0 by 2. For any other angle, what will it be? I0 by 2 cos square theta or not? Yes or no, yaar? This is transmission axis of
Yes, sir.
polarizer. This is also transmission axis of polarizer, but this is our transmission axis of analyzer. What is the angle between them? 45 degrees. Theta is given as 45 degrees. And they are mentioning that this value, the intensity of the polarized light emerging from the analyzer, how much is this intensity? They are saying this intensity is 2I0. The intensity of unpolarized light, how much is how much they are asking, guys. So can I directly solve it or not? So I0 by 2 cos square 45 should be equal to what here? 2I0. So I want to find, or basically you consider this as I only. So I'll get I by 2. Here I'll get I by 2 cos square theta. So this I by 2 cos square theta, they are saying how much its value is? 2I0, guys. They are asking us to find I value. What is cos square 45? Cos 45 is 1 by root 2. Cos square will be 1 by 2. So I by 4. So what will I get I value as? You will get it as 8I0, guys. Is this clear?
Yes,
Is this
sir.
clear? I hope you have understood, all of you. Yes or no, yaar?
Yes, sir.
Right. Let us do next question. Angle of polarization for a medium is given 53. Critical angle they are asking. Do we know the relation? What is the relation? Tan IP sin IC should be equal to 1. So what we can write? Sin IC value will be equal to 1 by tan IP, which is 1 divided by tan 53. Tan 53 happens to be 4 by 3, guys. So 1 by tan 53 will be 3 by 4. So what will critical angle be? It will be sin inverse of 3 divided by 4. समझ गया? Clear?
Yes, sir.
The distance between the slits as shown in the figure is 5 lambda. Okay. Where are these slits? I think these two dotted lines are the slits, guys. The distance between the slits as shown in the figure is 5 lambda. The angle theta where central maxima is obtained. It means the source has got shifted below or not, guys? Yes or no? Is it lying on the is it lying on the what we can consider? Is it lying on the perpendicular bisector of the slits? No, it is not lying on the perpendicular bisector. So they're asking the angle theta where central maxima is obtained. So for this question, what we can do is, let us imagine this is our horizontal, right? We have a slit here, we have a slit here. Okay. And how are rays coming, guys? They are coming from, so if I imagine this is the perpendicular bisector of the slits. Okay. So the distance between the slits as shown in the figure is 5 lambda. They're asking us where lambda is the wavelength of the light used. The angle theta where central maxima is obtained. So they're asking what would be the location of central maxima, guys. So for central maxima, so what we can consider, देखो, I should say that for central maxima formation at that point you should not have any path difference, guys. Now you see this is one light falling onto the slit. This is also another light falling onto the slit. Both are parallel lines or not? Yes or no? Are they both parallel lines, guys? But if you observe them, which will travel more distance? They are coming from infinity again. Which will travel more distance, beta? Will first one travel more distance or not? By how much more it will travel? What I'll do is from second slit, I will just drop a perpendicular. From second slit, what I'll do, I'll just drop a perpendicular. So it has traveled this much more distance, beta. This much more distance it has traveled. So what will that distance be? So they have given this angle as how much? 60 degrees. So automatically will this angle become 30 degrees or not? This is your D. This is perpendicular. So what is the initial path difference? Is delta x if I consider. How much will I get delta x value as? Is it adjacent to 30 degrees or not? So what will I write, beta? Delta x will be D cos 30. Can I write it something like this? So how much will this be? D divided by 2. Is that clear? Yes or no, yaar? Yes. Now which ray has to travel more distance? Which ray has to travel more distance, beta? The first ray initially traveled more distance. Now which ray has to travel more distance? Second ray has to travel more distance. So what is the value of theta they are asking here? So delta x we got it as D divided by 2, and what we can write delta x value as? So we D value we got 5 lambda, no? So delta x value we can write it as 5 lambda divided by 2. Okay. So now you tell me how many fringes did the central maxima shift, guys? How many fringes did the central maxima shift here? 2n minus 1 lambda by 2 if I take. Can I say 3 fringes it has shifted upwards? 5 lambda by 2 we got, no? The distance between the slits as shown in the figure is 5 lambda, where lambda is the wavelength of light used. The angle theta where central maxima is obtained, they are asking. So there is some initial path difference between these two. Finally, I need to remove that particular path difference. They are asking us to find theta value. What I can do now? Now, second ray has to travel more distance, guys. Again, they are coming out as parallel lines only. Yes or no? They are again coming out as parallel lines only. Okay, chalo. Very easy concept, guys. So can I take this is theta again? Right. So now which has to travel more distance? Second one has to travel more distance. So how will I find that out? You see, second has to travel more distance. So what I'll do from this first one, I'm just going to drop a perpendicular again onto this. I'm dropping a perpendicular. So for better understanding, you can just consider it. This is perpendicular, guys. Imagine it is perpendicular. So if this is theta, what will I get this value as? 90 minus theta. Yes or no? If this is perpendicular, this completely is perpendicular or not again? So if this is theta, how much will this angle be? Again 90 minus theta. What will this angle be, beta? This angle will again be theta. So how much should this be? This should also be equal to delta x only or not? You got my point. For there to be no path difference, both the waves should travel same distance. So first light has initially traveled how much distance more? Delta x. Second also should now travel after it is crossing the slits. Should now travel delta x distance more only or not? So what is this? If this
Yes,
is
sir.
theta, this you got 90 minus theta. So automatically this also became theta, guys. Right? So for theta, this is opposite side. So here what we can write delta x as, I can write it as d sine theta. Clear all of you? So what we can write here, d sine theta value can be written as d divided by 2. The sine theta value, I'll get it as 1 divided by 2. So theta value, I'll get it as 30 degrees, guys. Is there 30 degrees option? I think 30 degrees should be the answer for that. You got my point? Did you
Yes,
all
sir.
understand, all of you? See, initially first ray traveled more distance. How much more distance? Delta x. Where will central maxima be formed? At that particular position, where there is no path difference. It means now after crossing the slits, second wave should travel more distance or not? How much more distance? Again delta x distance only. So on left side, delta x value was d cos 30. On right side, delta x value is d sine 30, guys. So d sine theta we got. Cos 30 is root 3 by 2, no yaar? Cos 30 is root 3 by 2, no? Cheptalarendra bhai. So here we will get it as root 3 d divided by 2. And what is delta x on the other side? I can write it as d sine theta will be equal to root 3 d divided by 2. So sine theta value, I'll get it as root 3 divided by 2. Theta value will be again 60 degrees only, guys. But I don't think you should get 60 degrees here. Did I make any mistake? Just check. Just see if I have done any mistake, or keep this question aside. We will just come back to this question. It should either be 30 or 45, guys, to my knowledge, because they are converging again, right? So these two angles will be equal when they are straight lines again. Yes or no? They're vertically opposite, but they are not vertically opposite here. ये 60 है तो ये 30 हो गया, ये d है तो ये d cos 30 हो गया. Okay, correct. ये theta है, so I've dropped a perpendicular over here. This is 90 degrees, so automatically this will also be 90 degrees only. If this is theta, this is 90 minus theta. This will again be theta. This is d sin theta only will get. So d sin theta value will be equal to d cos 30, guys. So sin theta value will be cos 30. Cos 30 is nothing but sin 60. Theta we are getting 60 only. Let me check once again that question. Okay, keep that aside, guys. I'll just cross check that question once again. Next question, let us see. What they are saying is, when the angle of incidence is 53 degrees on a surface of glass slab, it is found that reflected ray is completely polarized. When will reflected ray be completely polarized? If the incident ray is incident at a particular angle called as polarizing angle. So here, can I directly tell that polarizing angle will be 53 degrees or not, guys? So what we can write? We know tan IP value is nothing but your mu. So mu value can be taken as tan 53, which turns out to be 4 by 3. They're asking speed of light. So what we can write mu value as? We know mu value is c divided by v. So v value will be c divided by mu, which turns out to be 3 into 10 power 8 whole divided by 4 by 3. 9 by 4 you will get, guys, which I can take it as 2.25 into 10 power 8 meter per second. Clear? Yes or no? When will reflected light be completely polarized? If incident light is incident at a particular angle called as polarizing angle. So they have already mentioned that it is incident at 53 degrees, guys. So here the polarizing angle should be 53 degrees, and when the angle of incidence is 53 degrees on the surface of glass slab, it is found that reflected ray is completely polarized. So this should be the answer. Clear, everyone? Is that clear?
Yes,
or
sir.
no? Next question, let us see. Light of wavelength 600 nanometer is incident on a slit of width 1 mm. So only one slit is given. Resulting diffractionist pattern is observed on a screen at a distance capital D. If the fringe width of central maxima is equal to 2 mm, right? What is capital D value they are asking? So what is fringe width of central maxima? Is it 2 lambda capital D by small a or not, guys? And how much is it given as? It is given as 2 mm. So lambda is given, slit width is given, capital D they are asking. What will capital D value be? So I can write it as, so anyhow, so 2 into 600 nanometer is given, guys. So I can write 6 into 10 power minus 7 meters into capital D. A value is given as 1 mm. So 1 into 10 power minus 3 should be equal to 2 into 10 power minus 3. So we can cancel this 2 and 2 will be out. 10 power minus 6 you will get. So 10 power 10 by 6 you will get, guys, D value as 10 by 6 you will get, which turns out to be how much? 5 by 3 meters. Clear? Direct question only. Width of central maxima is 2 lambda capital D by small a. Small a is given, lambda is given, and this whole width is given. So can we find capital D value or not? Yes or no, everyone? Yes, we can find capital D value. I hope it is clear, all of you. Width of central maxima and diffraction. Okay, are we connected?
Yes, sir.
Next, in Young's double slit experiment, fringe width is found to be 0.6 mm. Okay, so what is given? Beta value is given to us. Beta value is given as 0.6 mm. If the whole apparatus is immersed in a liquid having refractive index 1.5, new fringe width they are asking, guys. So what is new fringe width? As you all know, it will be beta divided by mu. So I can write it as 0.6 divided by 1.5 value will be 3 by 2. So you will get it as 0.4 mm. Direct question again. Whenever Young's double slit apparatus is immersed in a medium, fringe width will decrease. Intensity of fringes will remain same. Yes or no? Yes or no, yaar? Next question, let us see. Two sources with equal intensity have a varying phase difference. If the waves from these sources interfere, then resultant maximum intensity is how much they are asking. So what is resulting intensity, you tell? Again, if I1 is equal to I2, right? They have some varying phase difference, it seems. Whatever may be that varying phase difference. So when will you have maximum intensity? Constructive interference. Yes or no? So what is resulting intensity if I1 and I2 are equal? We know the resulting intensity, will it be given as 4I0 cos square 5I2 or not? So in this case, what will maximum intensity be, beta? Maximum intensity, you know, it will be equal to what? 4I0. And what is minimum intensity going to be? 0. So they are asking us what is maximum intensity. Can I say it is 4I0, all of you?
Yes, sir.
Yes or no? Direct case again. For light diverging from a point source, for light diverging from a point source, choose the correct options. For point source, which type of wavefronts? Wavefront is cylindrical, it seems, correct? Wrong.
Yes.
Wavefront is spherical, it seems, correct? Yes. Intensity increases in proportional to the square of the distance. Will intensity increase, guys? For point source, what is intensity? Directly proportional to r square. Is it directly proportional to r square?
Say inverse.
No, inversely proportional. So will it increase with distance? No. So what will be correct statement, guys? Only second statement. Wavefront is spherical will be correct statement. Understood, all of you?
Yes,
Yes
sir.
or no? Right. Now you see. Consider a light beam incident on a glass slab from air at Brewster's angle, polarizing angle. So this is your refracted light. This is also again refracted light. So will refracted light be partially polarized or not?
Yes, sir.
Yes. So here you have a partially polarized light. Now what is happening? A Polaroid is placed in the path of the emergent ray and rotated about an axis passing through center and perpendicular to the plane of Polaroid. What is going to happen? They are asking, guys. So is it partially polarized or not, guys? Yes, it means two components it is going to have. Let us see the options. I have already discussed this point again. For a particular rotation orientation, there shall be darkness as observed through the Polaroid. One first option. Intensity of light as seen through the Polaroid shall go through a minima but not zero for two orientations of the Polaroid. Correct? It will be not zero again. Intensity of light as seen through the Polaroid shall be independent of rotation, it seems. Will it be independent of rotation? No, it will depend on rotation again. Intensity of light as seen through the Polaroid shall go through a maxima for 8 rotations of the Polaroid. For how many rotations? For how many rotations? 2 rotations, guys. This is wrong. It is independent of the rotation, it seems. Is this also wrong or not? For a particular orientation, there shall be darkness as observed through the Polaroid. See, the emergent light will be which light again? It is going to be an unpolarized light. So when unpolarized light is incident on a Polaroid, I don't know how its transmission axis is. You take this transmission axis. You take any transmission axis. What will be our intensity? You will get polarized light or not? Yes. So for a particular orientation, there shall be darkness as observed through the Polaroid. There will not be any darkness, guys. I think third option also, if we just keep it aside as of now, the intensity of light as seen through the Polaroid shall go through a minima but not zero for two orientations of the Polaroid. Because it is unpolarized light, guys, definitely you are going to have, however maybe the transmission axis, you will get polarized light or not. So this will be wrong. I think third option will be correct statement, guys, for this. Because if it was polarized light, then whatever I have discussed before would be correct. But here the emergent light will again be an unpolarized light. So unpolarized light is falling on a Polaroid. So however may be the transmission axis, how much intensity will come out of it? If this is I naught, what will be the intensity coming out of it, guys? I naught divided by 2. Clear, all of you? Understood or not?
So,
Right.
but if you consider it as x, z-axis, would it be perpendicular to both x and y? So,
No. It depends on. In that case, it is unpolarized light. No, in that case, it can be along x and it can be along y. It can be along x or it can be along z. It can be y or along z. Yes or no? These two vectors should be perpendicular. So irrespective of, they are saying a Polaroid is placed in the path of the emergent ray and rotated about an axis passing through the center and perpendicular to the plane of the Polaroid. So if Polaroid is like this, right, it is rotated in this manner. So transmission axis is getting rotated like this. So here it is behaving as our polarizer. It is behaving as our polarizer. So when unpolarized light is incident on polarizer, whatever may be the transmission axis, polarized light will come out or not? Yes. How much intensity? I naught by 2. Clear? This is not a case of what I have explained before, guys. It is a case of unpolarized light falling on a polarizer. So whatever may be the transmission axis, definitely I naught by 2 light will be coming out. Okay. Is that clear, all of you?
Yes, sir.
Let us move to the next question. Light waves from two coherent sources of intensity ratio 81:1. So what is given? I1 by I2 value is given, guys. So what is I1 by I2 value given as? It is given as 81:1. What is the ratio of maximum to minimum intensity they are asking? Can you please tell? What is the ratio of maximum to minimum intensity? If you remember, if I take this as beta, what is ratio of maximum to minimum intensity given as? Root beta plus 1 divided by root beta minus 1 whole square or not, guys? So if beta is 81, what will root beta be? 9. 9 plus 1 will be, so this is root over 81 plus 1 divided by root over 81 minus 1 whole square. So can I write it as 10 divided by 8 whole square or not? Which I'll get it as 5 by 4 whole square, which turns out to be 25:16. Is that clear? Is that clear, all of you? The ratio of maximum to minimum intensity will be given as root beta plus 1 divided by root beta minus 1 whole square. If you know the ratio of the intensities, then I can write maximum to minimum intensity as root beta plus 1 divided by root beta minus 1 whole square. I hope it is clear, all of you. Yes or no? Next question, let us see. Light of wavelength 500 nanometer is incident on two slits separated by 1 mm in Young's double slit experiment. What is the width of each bright band if screen is? What is the width, guys? Whether you take a dark band or bright band in Young's double slit experiment, are their width same or not? How much is it? Lambda capital D by small d. So can we write it? 500 nanometer is given, so I can write 5 into 10 power minus 7. Capital D value is given as 1 meter and small d value is 1 into 10 power minus 3, guys. So I can write it as 5 into 10 power minus 4, or I can write 0.5 into 10 power minus 3 meter, which turns out to be 0.5 mm. Clear? Direct question? Yes or no, everyone? Yes or no, all of you? In Young's double slit experiment, I have told you, whether you take central maxima, whether you take first bright fringe, whether you take third minima, you take any fringe, guys, fringe width will remain same, lambda capital D by small d. In diffraction, central maxima will have a width 2 times width of any other fringe. The width of any other fringe in diffraction will be lambda capital D by small a. Width of central maxima will be 2 lambda capital D by small a. Clear? Yes or no? What is the angular spread between central maxima and first ordered maxima of diffraction pattern? Okay, central maxima and first order maxima, guys, due to a slit width is given. I have told you the angular position of maximas. So what is the condition for maximas, guys? A sine theta n should be equal to 2n plus 1 into lambda divided by 2 or not. So what will I get sine theta n value as? I'll get it as 2n plus 1 into lambda divided by 2a. What is angular position of nth secondary maxima? Sine inverse of 2n plus 1 into lambda divided by 2a. So they are asking us what is the angular spread between central maxima and first ordered maxima. It means I need to find the angular position of first maxima, guys. What will theta 1 value be? I can write it as sine inverse of, if n value is taken as 1, you will write it as 3 lambda divided by 2a, guys. So I'll get it as sine inverse of 3 into, what is lambda value given as? 600 nanometers. So I can write 6 into 10 power minus 7 divided by 2 into 0.25 mm you can take. 0.25 into 10 power minus 3 you will get, guys. So 2 into 0.25 will be 0.5. I can write 6 again. 6 6 you will get it as 36, guys. So theta 1 value will be sine inverse of 36 into 10 power minus 4 you will get. Or I can write it as sine inverse of 3.6 into 10 power minus 3. Because 3.6 into 10 power minus 3 is very small, I can say theta 1 is approximately equal to 3.6 into 10 power minus 3 radian. Understood, all of you? Is that clear, everyone? Angular
Yes,
position
sir.
of nth maxima, nth secondary maxima, what will it be? Sine inverse of 2n plus 1 lambda divided by 2a. And whenever angle is small, sine theta or sine inverse theta can directly be written as theta itself, guys. Clear? Understood, all of you?
Yes.
Yes, if we see, light of wavelength 500 nanometers diffracted by an apparatus having fringe width of 2 mm. What is Fresnel distance? It is very important, guys. Basically, Fresnel distance is given by ZF, which will be taken as a square divided by lambda. Okay. So up till this distance, up to Fresnel distance, ray optics laws will hold good. Above Fresnel distance, ray optics laws are not going to hold good. We will solve problems using wave optics principle, guys. So what is Fresnel distance here? It is given as a square by lambda. Width, as you can see, it is 2 into 10 power minus 3. So 2 into 10 power minus 3 whole square divided by wavelength can be written as 5 into 10 power minus 7. So what will our Fresnel distance be, beta? 4 into 10 power minus 6 you will get, and 5 into 10 power minus 7 you will get. 4 into 10 power minus 6 divided by 5 into 10 power minus 7, which turns out to be 40 divided by 5, which is 8 meters, guys. Clear, all of you? It's very important again. Fresnel distance will be given as a square divided by lambda. Up to this distance, laws of ray optics will hold good. Above this distance, we cannot solve questions by applying ray optics laws, guys. We will be solving that question by using the concepts of wave optics. Understood, everyone? Yes or no? I hope it is clear, everyone. Next question, let us move ahead. Spectral line has been given for a given element in light received from distant star is shifted towards longer wavelength light. Longer wavelength light means which shift? Red shift. Red shift means, is it going to move away or not, guys? So what is the speed of the star in the line of sight? Line of sight means along the line joining source and observer, guys. So what we can write? Delta lambda divided by lambda. Is it V by C or not? Yes or no? So what is given to us, beta? It is given the delta lambda by lambda into 100. This percentage is given 0.025. So what we can write delta lambda by lambda as? I can write delta lambda by lambda as 0.025 divided by 100 should be equal to V divided by C. So which we can also take it as 25 by 1000. So we can write V by C value as, so this can be written as 25 into 10 power minus 3 I can write. So overall you will get it as 25 into 10 power minus 5. So V value will be 25 threes, it is 75 again. So 75 into 10 cube you will get. or I can write it as 7.5 into 10 power 4 meter per second. Understood everyone? Direct formula again. Delta lambda by lambda is V by C. They have given percentage shift in the wavelength, guys. From there I have found out delta lambda by lambda. Because it is shifting towards longer wavelength, I can say it will be red shift. It means the star is moving away from the element, guys. Okay. Is that clear?
Yes, sir.
Yes, sir.
Now you see here. Initially, two polarizing sheets are placed with their planes parallel so that light transmitted is maximum. So what is the condition? When will light transmitted be maximum? When this is one transmission axis. If the other transmission axis, if they are together along the same direction, if they are parallel, will I get maximum light or not, guys? Now what they are asking, through what angle must either sheet be turned so that light intensity drops to half of the maximum value? First of all, let us find what is the maximum value. Here if I say I naught, what will I get here? I naught by 2. Again, what will I get here? I naught by 2 only. Now what they are saying, if we are rotating one of the sheet, let us say I have rotated it by how much angle, beta? Let us consider we have rotated the transmission axis of the analyzer by a certain angle theta. Okay. So what is the intensity I'm going to get here? This is I naught, unpolarized light. Here I'll get I naught by 2. Here I'll get I naught by 2 cos square theta. How much is maximum intensity here? This is our maximum intensity, beta. Yes or no? Now they are asking, by what angle should one of the sheet be rotated such that the resulting intensity is how much, beta? Half of the maximum value. It is I max divided by 2 they are asking. So what we can write here? I naught by 2 cos square theta. What is I max by 2, beta? If I divide this by 2, will I get I naught by 4? Yes. So what will cos square theta value be? It will be 1 by 2. Implies cos theta value will be 1 divided by root 2. So what will theta value be, beta? 45 degrees. Clear? Yes or no? You will get 45 degrees also, and one more angle, right? You will also get 135 degrees, guys. Both 2 and 3 will be correct statements. Clear, all of you? Why? Because cos 135, if you take, it is, see, cos theta value can either be plus 1 by root 2 or minus 1 by root 2, guys. So I'll get 45 degrees and 135 degrees. Both will be correct again. Clear, all of you? Plus 1 by root 2, 45. Minus 1 by root 2, 135. Okay. Is that clear? Understood, everyone?
Yes.
Yes, sir.
Initially, maximum light is transmitted. When will maximum light be transmitted? If the transmission axes are parallel to each other. Now they are saying one of the sheet is rotated. Means obviously transmission axis will also rotate. By what angle should it be rotated such that the final transmitted light has an intensity half of the maximum value? So what is the maximum intensity coming out? I naught by 2. Half of that value will be I naught by 4. So I'll equate I naught by 2 cos square theta to I naught by 4. So two angles you will get, guys. Understood, everyone? Understood, all of you?
Yes.
Next question, let us see. Laser light of wavelength 630 nanometer incident on pair of slits produce an interference pattern where bright fringes are separated by 8.1 mm. So successive fringes separation is nothing but bright fringe. Another laser light produces interference pattern where bright fringes are separated by 7.2 mm. What is the wavelength of second light they are asking? Very direct question. Yes or no, Vedna? What is beta value? Lambda capital D divided by small d. So we know beta value is directly proportional to lambda. So what we can write here? Beta 2 divided by beta 1. Can I write it will be lambda 2 divided by lambda 1? Yes or no? They're asking lambda 2 value. What will lambda 2 value be? It will be beta 2 divided by beta 1 into lambda 1. What is beta 2? 7.2 mm. What is beta 1? 8.1. What is lambda? 630 nanometer. So can I write it as 8 by 9 times of 630 or not? So what will I get? 9 ones, 970 you will get. So how much should be the answer, guys? 560 nanometer will be our answer. Clear?
Yes, sir.
Yes or no? Fringe width will be directly proportional to wavelength, guys. So beta 1 by beta 2 can be written as lambda 1 divided by lambda 2. Understood? Understood all of you?
Yes, sir.
In a single slit diffraction experiment, first minima of red light 660 nanometer coincides with first maxima of another wavelength lambda 2. What is the value of lambda 2 they are asking? First of all, please tell me what is angular position of first minima? What is angular position of first minima? Sine inverse of lambda. When I'm using one light, guys, can I write lambda 1 divided by? What is angular position of first maxima? I'm using second light, guys. Can I write it as sine inverse of 3 lambda 2 divided by 2a or not? Yes or no, all of you? For small angles, what we can write? Will sine theta value become theta or not, guys? For small angle. So I can say if I am using lambda 1 wavelength, the angular position of first minima is what? Lambda 1 divided by approximately equal to. And if I am using second wavelength, the angular position of first maxima is approximately equal to 3 lambda 2 divided by 2a. What they are saying, first minima coincides with first maxima. So at the same location they are formed. So what we can write, lambda 1 by a will be equal to 3 lambda 2 divided by 2a. So I can write lambda 2 value will be 2 by 3 times of lambda 1, which is 2 by 3 times of what is lambda 1 value given as? 660 you will get, which can be taken as 440 nanometer. समझ गए?
So would you explain this also?
अरे यार, तुमने फॉर्मूला याद किया है वैष्णव?
Yes, sir.
You know what is angular position of first minima? What is angular position of first minima, guys? In diffraction pattern, sine inverse lambda by a. So when I am using first wavelength, one wavelength I am using, in while I am using that wavelength, what will be angular position? Sine inverse lambda 1 by a. So if this value is small, I can directly write lambda 1 by a. While I am using second wavelength, there the position, angular position of first maxima is sine inverse 3 lambda 2 by 2a. Are you clear about this? 2n plus 1 lambda divided by 2a will be angular position. So when I'm using second wavelength, angular position of first maxima formed by using second wavelength can be taken as 3 lambda 2 by 2a. Now they are saying the first minima formed while using lambda 1 wavelength and first maxima formed by while using lambda 2 wavelength are at same point. So can I say angular positions will be same or not? When they are at same point, its angular position will be same again. Clear?
Yes, sir. Clear.
Next case, let us see. In Young's double slit experiment, green light with wavelength is used. 60 fringes were seen in a field of view. So in some region you consider 60 fringes were seen, guys. Now you are using sodium light. They're asking in the same field of view, how many fringes are observed? Again, very direct question. Let us say there are some length, guys, some x length we are taking. In this x length, you have 60 fringes, or let us say n1 fringes. So what would be width of each fringe? Lambda 1 capital D by small d can I write? While I am using first wavelength. In the same field, if I am using some other wavelength, let us say n2 fringes are formed and each width will be lambda 2 capital D by D. Are left hand sides equal? Did you understand how I have written this, guys? There is some region they have given. If I use first wavelength, there are 60 fringes formed. In the same region, if I am using some other wavelength. How many fringes are formed? They are asking. So can I write this? Did you understand this, everyone? If I'm using lambda 1 wavelength, I'm assuming n1 fringes are formed. Width of each fringe, it is lambda capital D by small d. So that x value will be n1 into lambda 1 capital D by small d. In the same manner, if I use second wavelength, n2 fringes are formed. So number of fringes into each fringe width, that will again be equal to x. So what we can write here, from this I can write n1 lambda 1 capital D by small d should be equal to n2 lambda 2 capital D by small d. So what we can write, beta? N1 lambda 1 will be equal to n2 lambda 2. They're asking us to find the value of n2, which I can write lambda 1 by lambda 2 into n1. Okay. So what is lambda 1 given as? Lambda 1 is 5500. Lambda 2 is 5890. What is n1? 60 fringes, guys. So you can solve for this. 0 and 0 will get cancelled out. How much will you get? Just 56 you will get. Okay. So you are going to get this as 56, guys. Because it is less than 1, so it will be less than 60, guys. Just less than 60 you will get. Understood, all of you? Yes or no?
Yes.
Next question, if you see, a plane surface separates a denser medium of refractive index 1.5 from air. A plane wavefront traveling in air is incident on the interface of an angle of on the interface at an angle of incidence 30 degrees. What is angle of refraction they're asking? What will apply, beta? You can take an interface, something like this. Okay. So what they are saying, a plane surface separates a denser medium from air. A plane wavefront traveling in air is incident on the interface. So I'll just show you. It's a very important concept again. So plane wavefront, when I'll get, you have parallel incident rays like this. Okay, this we will study in Huygens principle, guys. So this is one point of incidence. This is one point of incidence. And if this is our wave propagation, wavefronts will be perpendicular to wave propagation or not? Yes or no, beta? So this will be our incident wavefront. This is our incident wavefront, guys. And this is the normal. Yes or no, guys? This is the normal. So light will travel, light is traveling from, separates denser medium from air. So let us say it is traveling from air to that denser medium 1.5. So light will bend towards the normal or not? So you will get, this is your refracted ray. Again, it is light, again it will be a wave only. This is our wave propagation. So how will wavefronts be, beta? Again you can see wavefronts will be perpendicular to the direction of wave propagation. Clear, all of you? So you see this angle will be our R. These orange ones are wavefronts, guys. These are planar wavefronts again. You can consider them to be our wavefronts because wavefronts will always be perpendicular to the direction of wave propagation. These yellow points are points of incidence. Okay, yellow points are points of incidence. Now please tell me, what will this angle be? This angle is I. Okay, so automatically what will this angle be, beta? They're asking us to find what? R value they're asking us to find. Yes or no? So again, you can directly apply Snell's law from this. So what are we going to get? So if this is I, how much will this angle be, beta? Because this total angle will be 90 degrees again. Will this be 90 minus I? Yes. So again, what will this angle be? I. Again, you can consider this is 90 degrees. Okay. So what will this angle be again? 90 minus I. This total, this is 90 degrees again. These two are 90 degrees, guys. So if this is R, you will get this as 90 minus R. Automatically, this will become R, guys. So we can apply Snell's law directly from this. So what are we going to get? 1 into sine I value will be equal to mu into sine R. So what will sine R value be, beta? 1 by mu times of sine I. Mu value is given as 1.5. So you will get it as 2 by 3 times of sine 30 you will get. Okay. What are we going to get? Sine 30 is how much? 1 by 2 or not? So what will sine R value be, guys? Sine R value will be 1 by 3, which I can write it as 0.33. So R value will be sine inverse of 0.33, guys. Okay. So this is Snell's law again. You can directly apply Snell's law, but here I've just shown you what will be the wavefronts, guys. Wavefronts will always be perpendicular to the direction of wave propagation again. Understood, all of you? Yes or no?
Yes, sir.
Right. Next, let us see how many more questions are there. 1, 2, 3, 4, 5, 6. Around 10 to 12 questions are there, but they are going to be of same model, guys, again. Okay. What I'll do is they are mostly going to be of same model, which I believe you can solve, guys. Okay. So I'll just discuss few more questions. Okay. Usually they are going to be of same models only. So if they are of same models, we'll keep it aside. Young's double slit experiment, if slits ratios have a width of 4:1, what is the ratio of maximum and minimum intensity they are asking, guys? So basically the widths are given. So let us imagine their widths to be x1 and x2, guys. Again, it is an important question. So here they have given x1 by x2 value as 4/1, their widths again. Basically, intensity will be proportional to width square, guys. So what we can write here, I1 divided by I2 will be equal to x1 divided by x2 whole square. Okay. So you can write it as x1 divided by x2 whole square. So what will I get here? I'll get it as 4:1 whole square. So will this be 16:1 or not? Now they are asking us what is the ratio of maximum to minimum intensity, guys. So what will be maximum to minimum intensity? It will be root over I1 by I2 plus 1 whole divided by root over I1 by I2 minus 1 whole square. So root 16, you know, it is 4. 4 plus 1 will be 5. 4 minus 1 will be 3 whole square. What will you get this as? 25:9 we should get, no? There is no option available there. If two slits in Young's double slit experiment have width in the ratio 4:1, what is the ratio of maximum minimum intensity in interference pattern? X1 by X2 is 4:1. Okay. If I take direct proportionality, again, intensity is basically proportional to diameter square, guys. Or maybe they are directly proportional to width again. So if I take 4:1, what will I get? 3 by 1. 9:1 option is there. 25:9 I'm getting. Okay. So you take intensity is directly proportional to width, guys. But I think diameter square, so I remember. Okay, you take it as I1 is to I2 is directly proportional to x1 is to x2. For width, you take like this. So you'll get it as 4:1 only. So I can write it as root 4:2 again. 3 divided by 1 square you will get, which is 9:1. When interference of light takes place, what will happen? They are asking. What is interference again? It is phenomena of redistribution of energy, guys. So energy will be conserved and it will be redistributed, guys. So that is interference again. Conservation of energy law holds and energy will be redistributed. So interference is a phenomena of redistribution of energy which will take place because of superposition of waves, guys. So when interference is taking place, conservation of energy will hold good and its redistribution will take place. Next question, if I see one more question we'll do and we'll end the session, and I'll post the test because majority of them will be of same type, guys. Again, the slits are 1 mm apart from each other and illuminated with light of wavelength 5 to 10 power minus 7 meters. If the distance of the screen, the distance of third dark fringe from central maxima. Now, very direct question, what are positions of nth maxima, beta? If you remember, positions of nth maxima will be 2n minus 1 lambda capital D divided by 2d. They're asking what is the distance of third dark fringe. So I want to find, sorry, nth minima, not maxima. Position of nth minima will be 2n minus 1 lambda capital D by 2d. I want to find third minima. What we can write, beta? I'll write it as 5 lambda capital D divided by 2d, which is 5 into lambda value is given as again 5 into 10 power minus 7 meters. Capital D value is given as 1. 2 into small d value is 1 mm apart, guys. 10 power minus 3 will get 25 by 2. You will get it as 12.5 into 10 power minus 4, which I can write it as 1.25 mm. So it will be at a distance 1.25 mm, guys. First option. Clear? Let us do one more question because it is based on superposition of waves, guys. That would be the last question for today. Two coherent monochromatic light waves of amplitude 3a and 2a interfere at a point on screen where phase difference is pi by 3. Resulting intensity at that point will be proportional to what they are asking. So can I find resulting amplitude or not? What is resulting amplitude, beta? A1 square plus A2 square plus 2A1 A2 cos phi or not? So what will I get here? Under root of, what will this be? 3a whole square plus 2a whole square plus 2 into 3a into 2a into cos pi by 3. Cos 60 will I get or not? So what are we going to get the resulting amplitude as? 9a square, 13a square, cos pi by 3, and cos pi by 3 is 1 by 2, 2 and 2 will get cancelled out. So 19a square you will get under root of 19a square. So implies resultant amplitude square will be equal to 19a square, and we know resulting intensity will be proportional to resulting amplitude square, guys. So I'll get it as proportional to 19a square. Clear, all of you? Yes or no? So some questions we have discussed today, right? And majority of them will be of same model only, guys. So I would request you people to please, if other questions, whenever time permits, I'll complete them. Okay, there are hardly 10 questions left out, I guess. So those will be direct questions only, which we can do, guys, again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 questions, I think. 13, 14 questions are left out, guys, which will take around 20 minutes of time. So, but I think all of them are similar models only again, which you will be able to solve. So if there is any difficult question, I'll just identify from them and I'll discuss, guys. Okay. Clear, all of you? Is that clear, everyone?
Yes, sir.
Right. So I will share the test in the group. I'll share the Google form, guys, so that I'll share before 10 p.m. and if possible, please write it before 12. If not, I'll give a little bit of flexibility to write till tomorrow morning, guys. I'll keep that active only till 7 o'clock, and please ensure that you are writing the test. It will be a easy to moderate paper only, which you can solve, and we will also do the analysis of that paper, so that these two chapters will cover 20 marks in physics, guys, a maximum of 20 marks in physics. Okay, so at least when you are thorough enough with these chapters, you will be, even if you are doing one question wrong, you can get 16 marks again from these two chapters. So 16 marks is very big deal, guys. So please write the test, and we will do the analysis. I'll show it everything, and whichever question majority of them have done wrong, I'll explain those questions, right? And you will get the result as soon as you complete your test, guys. Okay, you will get to know the result. However, I'm not including negative mark. I'll just see in 20 minutes. I'll just do some research, and if I can award minus marks also, I'll add. But as of now, whatever I've done in that, negative marks are not there. But you will get to know how many questions you have correctly answered, how many questions you have left, how many questions you have wrongly attempted also. From there, I can get a manual score also, guys. Okay. So these two chapters we have done, and you will be writing the test till morning. You can I'll keep it active so that you can complete, guys. Okay. And whatever analysis is there in tomorrow's session, we will see the analysis first, and hopefully, if possible, I'll take 2-hour session tomorrow. Okay. Clear, all of you?
Yes, sir.
Yes.
Right. So that's it from my end for today. We will be meeting tomorrow.